Hello student, I am Professor Jayanta Chopde, working in Electronics and Telecommunication Department. I would like to welcome to this lecture on logic gates. Now in previous lecture, we have seen the different types of the number systems and conversion of that number system. After that, the binary arithmetic, and in that the binary addition and the subtraction. Then what is the ones complement and twos complement, and use of one complements and the twos complement of number. And the last, we also discussed the subtraction using the twos complement. Now in this lecture we are going to study the different basic logic gate, that is AND gate, OR gate and NOT gate. Then the introduction to universal gate, NAND gate and NOR gate, and XOR and the XNOR gate, and these gates are exclusive gates. After that we will discuss the Boolean algebra and the De Morgan's theorem, and what is the use of the Boolean algebra and the De Morgan's theorem. Now first, what is the logic gates? The logic gates are the basic building block of any digital system. It is an electronic circuit having one or more input and one output. Means output is 1. The relation between the input and output is based on certain logic. Hence this is called as the logic gates. The first basic logic gate is AND gate. AND gate has two or more input and only one output, this, and it perform this logical operation multiplication. This is the truth table. This is the two input AND gate. This is the symbol for the two input AND gate, and output is one output Y. Now this is the truth table. Truth table means for the different combination of input, this is different combination of input 0 0 0 1, change this B from 0 to 1, then change A 1 0 and 1 1. As number of inputs are 2, means we are getting the combination 4 combination 0 0 0 1 1 0 and 1 1. Then what is the output of this AND logic gate? Output is for the 0 0, output is 0, for 0 1 is 0, for 1 0 is 0, and for 1 1 output is 1. Means we can say that any one input is 0, output is 0. When both inputs are 1, that time only output is 1. And this equation y equal to a dot, mean this is AND operation, and this is logical multiplication, dot b. This is called as the logical expression for the AND gate. Now if we consider here the simple circuit, and here the light is connected, This is A, this is B. Now when light will glow or on, this is battery. When one A is 0 means this is open and this is short, that time no current will flow through this. Current will flow through this circuit only A is 1 and B is 1, means both are short. That time this is connected to this, with this, and this connection is there, and due to what happen, the current will flow. As current will flow means the output will be 1. Means for the AND gate, when both inputs are 1, that time the output is 1. This operation is called as the AND operation. The second operation is OR gate. This is 2 input OR gate, symbol for this 2 input OR gate. And this is the Boolean expression for the OR gate, that is y equal to A plus B. And this gate perform here this plus operator means logical operation or addition. Here this A plus B. Now for this, if any one input is high, here this B is high, here A is high for this condition, and here for 2 inputs are high, that time output is 1. This is the truth table for OR gate. And logic expression is y equal to A plus B. Then the NOT gate. For the NOT gate, the single input and single output. This gate is also called as the inverter, because it does the inversion of the applied binary signal at the output. Means if A equal to 0, A is 0, what is output? 1. Means this is invert, change. If input is 1, output 0. And here this symbol, this is the symbol for this, and this bubble indicate the inversion. Means 1, this becomes 0, and 0 becomes 1, inversion. And the Boolean expression y equal to A bar. The bar means inversion of this input signal. Then this NAND gate, and next one is the NOR gate. NAND gate and the NOR gate is called as the universal gate. Now this is the 2 input NAND gate, and NAND gate is the cascade combination of AND and NOT. Means output of the AND gate is given as the input for NOT gate, and the output of this NOT gate is the output of the NAND gate. Means we will draw the logic circuit is like this. This is the AND gate, and the output of this AND gate is given to inverter A, B, and this is Y. And we know the truth table for the AND gate. For the AND gate, only for both inputs are 1, that type output is 1. If any one input is 0, output is 0. Now this is the output for AND gate, and this output is invert. Means the truth table for this NAND gate becomes, for AND gate for 0 0, means if we write here A, B, Y, or here Y dash, this is the output of AND gate, and then Y output of NAND gate. Now for combination 0 0 0 1 1 0 and 1 1. For 0 0, for AND gate output is 0. Here this one is 0, this is 0 and this is 1. But NAND gate, output of this AND gate is given to the inverter, means this will invert this. I mean 0 becomes 1, this 0 becomes 1, again this is 1 and 1 is 0. Means for the NAND gate, see this is the truth table for this, for NAND gate. For the NAND gate, the output is 0 when both inputs are high. If any one input is 0, output will be 1. Then next universal gate is the NOR gate. Now this is the symbol for the two input NOR gate, and this is the Boolean expression for this NOR gate, and the NOR gate is again the combination of OR gate, and the output of the OR gate is given to the NOT gate A, B, Y. Here the Y equal to A plus B is output of this, and invert this means bar. This is the Boolean expression for the NOR gate. And the output for the NOR gate, recall output for the OR gate. For OR gate, if any one input is high, the output is high. Now invert this. Now here 0, 1. For OR gate, output is 1, but for the NOR gate, the output is 0 because this is inverted. Then 1, 0. For OR gate 1, this becomes 0. For 1, 1, 1 for OR gate, and for NOR gate this becomes 0. And for 0, 0, this is 1. Means for the NOR gate, we can say that if any one input is high, the output will be 0. Then exclusive OR gate, or this is called as the XOR gate. The two input XOR gate symbol is this one. And this is the truth table for this XOR gate. And the logic's Boolean expression Y equal to A bar B, and that equal to A bar B plus A B bar. This is the Boolean expression for XOR gate, and this one is the truth table for this. Now here it is for 0, 0, output is 0. For 0, 1, output is 1. For 1, 0, output is 1. And for 1, 1, output is 0. And the XOR gate is used in comparator, parity generator, and the checker. Now here if you observe this truth table, here when number of ones are odd, that time the output is 1. If this one is 0, 0, output is 0, and if this one number of ones are even, means 2 ones, that time output is 0. Then exclusive NOR gate. Exclusive NOR gate is obtained by connecting the output of the XOR gate to the NOT gate. This is A, B, this is Y. This is the symbol means this bubble indicate the inversion, this not operator. Means this symbol is like this. This is XOR gate followed by this inverter, and the inverter is replaced by this bubble. Bubble means inversion of this output of the XOR gate. This is A, B and Y. And the truth table for the XNOR gate is this. For XOR gate, we know that for 0, 0, for XOR, 0, 0 is 0, 0, 1 is 1, 1 odd 1, here again odd 1, and here even 1, 2, and this is 0. And the output for the XNOR gate, exclusive NOR gate, invert this, means the 0 becomes 1, 1 becomes 0, this becomes 0, and this become 1. 1, 0, 0, 1. And the Boolean expression for this y equal to a bar b bar plus a b, and this is denoted as a. This is XOR operation and inversion of that XOR operation. Then next one is the Boolean algebra. The Boolean algebra is used to analyze and simplify the digital logic circuit. Means using this Boolean algebra, we will analyze the digital logic circuit as well as we will simplify that logic circuits. And as this is simplified, the number of the gates are less and the complexity of that circuit will be reduced. And for that purpose, this Boolean algebra is used. This Boolean algebra uses the binary number, that is zeros and 1. Hence, it is also called as binary algebra. Now, there are different laws, and the basic are the 6 types of Boolean algebra laws. First one is commutative law, associative law, distributive law, then AND law, OR and inversion. Now here AND means the dot operator, OR means this plus operator, and this is the bar, a bar inversion. First one is the commutative law. Commutative law states the changing the sequence of the variable. Here this variable is a, b. If we take this AND operation between a and b, now instead of this, if we take this b dot a, if we change the sequence of this variable, then the result remain same. Similarly here a dot b dot c, this be b dot c dot a. You take any sequence, the sequence will does not affect the output of logic circuit. A plus b, that equal to, here this is OR operation, a plus b that equal to b plus a, or a plus b plus c that equal to b plus c plus a, like this. Then associative law is state that the order in which the logic operations are performed is irrelevant as their effect is the same. Means for the first case, here the a dot b, first this operation is performed, ANDing, and the resultant of this again ANDed with the c. Now instead of this, if we perform this ANDing operation b and c first and AND this with a, the result remain same. Means order does not affect the output, or a plus b plus c, here this first this operation, then this second operation, this is first, this is second operation, this remain same. Then distributive law state the following condition, that is A dot B plus C. Then take the ANDing operation, this along with this B and C means A dot B plus A dot C. Similarly, this A plus B dot C. Now here this is OR operator. Take this OR operator on B and OR operator on C. Then AND law. This law use the AND operation means this dot. A dot 0 that equal to 0. As this is 0, if any one input is 0 for AND gate, this is 0. A dot 1 is A. This is depend on A value. If A is 0, output will be 0. If A is 1, output is A 1. Hence A dot 1 is A. A dot A is A. If A is 0, means 0 dot 0 is 0. 1 dot 1 is 1. Hence A dot A that become A. Then A dot A bar, this last, A dot A bar, this is 0. If we take A equal to 0, then this is 0 dot 1. 0 dot 1 is 0. If we take A equal to 1, this becomes 1 dot 0. Second one is A bar. And this operator, this becomes 0. This is always 0. Then OR law, A plus 0 is A. If this one is 1, 1, 0, 0. A plus 1 is 1. If A is 0, this is 1. If A is 1, this is 1. Because for the OR operator, if any one input is high, output is high. Then A plus A is A. Again, this is 0. If A is 0, 0 plus 0 is 0. And 1 plus 1 is 1. Then 1 plus 1 bar is 1. Here, if we consider A plus A bar that equal to 1, first consider A equal to 0. Then this becomes 0 plus 1 that equal to 1. If A equal to 1, then this is 1 plus 0 that equal to 1. Means always A plus A bar that equal to 1. Then the last law is the inversion law. This law uses the NOT operation. The inversion law states that the double inversion of the variable result in the original variable itself. Means if we take this 0 and take the inversion of this, that becomes 1, and again take the inversion, double inversion, this becomes here 1, take double inversion, that becomes 0. Means original is 0, 0, that remains same. If this is 1, then first inversion is 0 and second inversion, first inversion is 0 and second inversion of this 0, that becomes 1. Means 1, this remains same. Hence this we will say that A equal to A double bar. Then De Morgan's theorem. De Morgan's theorem here state that this is which gate? This is the NOR gate. NOR gate is equivalent to the bubble input AND gate. This is the first De Morgan's theorem. That is first A plus B dot B. This is NOR gate. NOR gate is equivalent to bubble input AND gate. As the dot is there, means this is the ANDing of these two. NOR gate symbol is like this, and this is equivalent to A bar, means the inverter is there. This is A, this become A bar. Then B, B bar, and ANDing operation of these two. and the output is here A dot B bar. This is the first De Morgan's theorem, and the second De Morgan's theorem is A dot B that equal to A bar plus B bar. Means this gate is NAND gate, and this is equivalent to bubble input OR gate, A, B, this is A bar, B bar, and this is connected to this OR gate, means A bar plus B bar. This is output. Now if you observe this both theorem, here this is OR operation and A plus B and complete inversion of that. Now if we use this De Morgan's theorem, we will write, means this OR operation becomes AND operation, that is A, and separate inversion of the each variable A dot B. Means ANDing operation is converted into, here this OR operation is converted into ANDing with separate bar here. Similarly here this is ANDing operation, and that equal to break this. For this we write this is plus and separate this A bar and B bar. Means instead of this, first what is meaning of this, perform this operation and take the inversion of this, and meaning of this, first take the inversion of first variable, take the inversion of the second variable, then OR these two. Both are equal, this left hand side and right hand side. This is nothing but the De Morgan's theorem, and the De Morgan's theorem is used to simplify the Boolean expression. Then this is the proof of this De Morgan's theorem using the truth table. The first theorem, this NAND gate. This is the truth table for this NAND gate. Now you verify any one condition for this. Consider this condition. For this, this is 1 and this is 0. The invert this 1 becomes 0 and the 0 becomes 1. This is given to the OR gate, means any one input is high, output remain high for AND gate, means this is 1. Now see here, this is 1 and this is 1, means both A plus A dot B bar that equal to A bar plus B bar. Then the second De Morgan's theorem is A plus B bar, means this is NOR gate, truth table for the NOR gate, and that is equivalent to A bar dot B bar. Now verify any one condition. Let us consider this condition, last condition. For 1 1, we know that for NOR gate, for 1 1 output is 0. Now for this bubble input AND gate, consider this is 1, this is 1. For this last condition, this become 0, this become 0, 0 0, this become 0. Means this condition. Similarly, you can verify all these conditions. As all conditions are verified, truth tables Boolean equation must be equal. The truth tables are equal, therefore the Boolean equation must be equal. Hence we can say that A plus B bar that equal to A bar dot B bar. Example using the De Morgan's theorem. As we know that the De Morgan's theorem is used to simplify the expression, logical expression. Now this is the first. Now this is the complete bar and this is the dot operation. Means we will write this is F equal to X bar plus Z x bar plus Z into x bar y, and the inversion of this and this complete inversion. Now here there is ANDing operation. Now we will split this ANDing using the De Morgan's theorem is x bar plus Z plus x bar y like this. Here this ANDing is break up into OR and separate bar on these two. Means this is A dot B, this is A, this is B, that equal to A bar plus B bar. This is A bar plus B bar. Then simplify this, x bar plus Z plus x bar y, and here there is double inversion. One is for this as it is original, and second is due to using the De Morgan's theorem, and that will cancel out, and we are getting here this term is x bar y. Now as this is complete bar on this, again we can split this or to AND, as we know that A plus B that equal to A bar dot, this OR operation becomes dot B, means x bar dot x bar dot Z plus x bar y. This becomes x dot Z bar plus x bar y. This is the simplified Boolean expression of this Boolean expression. This is original Boolean expression. Then verify the Boolean expression, this left hand side that equal to right hand side using the Boolean's algebra. Now here there are 4 variables. If you observe this, then in first term, in second term and in third term, BD is common, and so if we take BD common and simplify this equation, Boolean equation using the Boolean law, A bar C plus for the second term, this is A bar C, and for the third term is this is A. Now we will verify whether this is BD or not. Then BD, take A bar common. If we take the A bar common, we are getting this one is C bar plus C bar plus C plus A. And what is A plus A bar? A plus A bar is 1. This becomes A bar into 1 plus A. This is BD. A bar plus A is 1, means again this will 1, means this is BD. Left hand side that equal to right hand side. And the Boolean or logical circuit for this B and D, these are the input, means this becomes only one gate, and this is ANDing operation this is y. Then second, verify the Boolean function. That equal to y x plus z. Now if we observe this first two term and this next two terms, here xy is common and here y z bar is common. Take xy common from first two term, this become 1 plus z bar, and from the second term y z bar, that becomes y z x plus x bar. Means we will rewrite this x y, this is 1, this is 1, x y plus y z bar. Take y common, then at last we are getting this result x plus z bar. And this Boolean expression for this x, this is z, x z, or operation is there, and this becomes x plus z bar, and ending with y. This y x plus z bar. This is logical expression for this Boolean, logical diagram for this Boolean expression. Then obtain the Boolean expression from this logical diagram. Means this logical diagram is given and you have to find out what is the Boolean expression for this. This is the output y in terms of this variable a, b, c. Consider here the output of this AND gate is y1, output of this OR gate is y2. Then what is y1? We'll write y1 that equal to a dot b. What is y2? y2 is y1 plus c. See here, this is a, b, this is y1. y1 is one input for this OR gate and c is the another input for this OR gate. This become y1 plus c. We will substitute this y1 value in y2. That time we are getting this is a dot b plus c. And what is y? Y is inversion of this y2. And so we will take the inversion of this a dot b plus c and invert this. Mean the Boolean expression is a dot b plus c and the bar of this. Now in this lecture, now this one is the assignment question based on this lecture, and in that in this assignment you have to solve these three questions. First question is list the universal gates and explain it. Explain XOR and the XNOR gate with the help of Boolean expression and the truth table, and verify this Boolean function using the Boolean algebra. Now in this lecture we discuss the basic gates. First, what is the gate? Gate is the logical gate are the basic building blocks of any digital system. And logic gates is the electronic circuit having one or more input and one output. and the relation between this input and output is based on certain logic, is called as the logic gates. In this lecture we studied the different basic logic gates, and in that AND operation, OR operation and the NOT operation. Then the universal gate. Universal gate is NAND gate. NAND gate is the combination of OR gate. NAND gate is the combination of NAND gate and NOT gate. NOR gate. NOR gate is the combination of OR gate and NOT gate. After that we discuss the XOR gate and the XNOR gate. XOR and XNOR gates are used in comparator and as well as for parity checker circuit. And after that we discuss the different Boolean algebra and Boolean algebra law and the De Morgan's theorem. Thank you. We stop here.